Alright, it is that day where we get to learn about the unit circle. Alright, unit circle, for those of you that are going on to take calculus, definitely something you need to know and understand very well. Or if you're taking like a physics class or something like that, it would be really helpful for you to understand where these values are coming from. If this is the end of the road for some of you, then perhaps this will be the only time. But it's just kind of fun to work with. You guys have been in my class for quite some time, and there was a painting on the back of the wall. That's a circle, and that's what we're going to work on today. So there should be in your materials, I hope, this unit circle drawing. So you can take that out, and actually yours won't have, oh yeah, it does have the angles on it, which I wish it didn't. Maybe it doesn't. I'm trying to think of how I scanned it in. So anyway, you're going to have that, and we're going to go through this. Now, you're not going to have an actual quiz on this like I normally would do, but you'll want to know it well. You will be able to use it on your tests as well here in the future, just because of our circumstances that we're working with. So, the unit circle is composed of really two triangles. And the two triangles that you need to know are your 30, 60, 90 triangle and your 45, 45, 90 triangle. Okay? So I'm putting three of them up here because it's going to be these three triangles that we are going to fit in that circle. And what's unique about the unit circle, and the reason why it's called the unit circle, is because it is working with a specific radius. And the radius of the unit circle is 1. That means that the hypotenuse of all of these triangles right here is going to equal 1. So now let's take a look at what would the other sides of your triangles be. If I were given that my hypotenuse here is 1, that means since my leg is n, if I were to divide by 2, that means that my height is going to be 1/2. Well then, if my base is n squared root of 3, and n is 1/2, that means that my base is the square root of 3 over 2. Now if I take the square root of 3 over 2 squared plus 1/2 squared, I will get 1, which is 1 squared. What about here? If I have a 45, 45, 90 triangle, and my two sides are the same, divide by the square root of 2, and I'm going to get the square root of 2 over 2. And we know that with a 45, 45, 90 triangle, it's a isosceles triangle, so both sides are the same. Now this next triangle is an exact replica of the first one that we did. We just put it on its side. The shortest side here is going to have to be that n value, the 1/2. And its height then is the square root of 3 over 2. These numbers right now are what we are going to now put into our unit circle. Alright, so let's start here, and I'm going to get into the angles and the radian measures here in a moment. I'm going to mostly talk about the coordinates at this point. But I just told you that the radius of this circle is 1. And you're starting here at the origin. What we should be able to do here, not knowing a whole lot, but knowing the radius is 1, to figure out what 4 of these coordinates are. Going 1 unit to the right, that means we have an x coordinate of 1, our y coordinate would be 0. Going straight up north, our x would be 0, our y would be 1. Going to the left here, our x would be -1, and our y would be 0. Going down here on the bottom, going down, we would be looking at x would be 0, and y would be -1. Now these 4 points those 4 points that we have right here are all because you have a radius of 1 and you're on the coordinate plane. So that means that this right here is 1 unit. This right here is 1 unit. Okay? That is what's being rotated around. So now we are going to take these triangles and put them into our circle. I have this 30, 60, 90 triangle, and I'm going to put it inside of our circle. Notice because of the radius here of being 1, that where this top of our triangle is right here, it is on our circle. And because of the dimensions that we have here, we can figure out exactly what coordinate that is of where it touches on our circle. Our x, our base here is the square root of 3 over 2, and our height is 1/2. Now I'm going to take that same triangle and I am going to put it in and rotate it, or put it in put it in 4 different positions, okay? And by doing that, it kind of makes this little bow tie. But all these points then here are going to correspond. The only thing that's different is some of them are positive and some of them are negative. When I'm over here in quadrant 2, this down here is going to be a negative square root of 3 over 2, still going up 1/2. Here, quadrant 3, both x and y are both negative. Quadrant 4, our x is positive, but our y is negative. Okay, next triangle that I'm going to do is I'm going to take our 45, 45, 90 triangle and put that into our circle that's here. And again, because its radius is 1, notice that this point is on our unit circle. Its base is the square root of 2 over 2, so I'm going over to the right, square root of 2 over 2. I'm going up square roots of 2 over 2. And so the coordinate that is associated with that point is the square root of 2 over 2, comma, square root of 2 over 2. Take that same point and now reflect it to the other quadrants. And now you're just going to notice that depending on which quadrant you are in, you have negatives or positives. The last triangle that we have then is going back to that 30, 60, 90 triangle. We're putting it on its side, and we're going to use the 60 degrees. We're going to put it right inside our circle once again. Here, once I see that radius is 1, notice this point is on the circle. As far as our coordinate goes, I'm going to the right 1/2, so there's our x coordinate, and we're going up the square root of 3 over 2. If I take that triangle and I reflect it into all of the 4 quadrants here, I'm going to have to zoom out so that you can see this. There we go. Now you can see that those coordinates are reflected all throughout. And you have now just completed the coordinates that are associated with your unit circle. Alright, so next thing we're going to do is go ahead and fill in the angle measures that are in our unit circle. And it's a circle, so you got to remember that. Over here, you're starting with 0 degrees. You make one complete rotation, you've got 360 degrees. Now we already talked about some of these angles already. We talked about 90 degrees. We talked about 180 degrees. We also talked about 270, and then obviously making around a 360. Now the other angles come in because you've got those triangles. That first angle that we were working with here is 30 degrees. When I go around the rest of the circle, then this 30 degrees is supplementary to the 150 degrees here. And that's just because that this angle right here is 30 degrees as well. So taking 180 minus 30 gives you the 150. This angle here is 30 degrees. So taking 180 plus 30 is going to give us the 210. 360 minus 30. And so you've got those 30 degree increments that are there. Then you've got the 45 degrees, which comes next. Well, here's 45 degrees. If we take 180 minus 45, you get 135. 180 plus 45, and you get 225. And you can kind of see the pattern. Another thing you might notice here is like right here, you've got a difference of 30 degrees, okay? Then it goes to 45. We'll notice right here between 30 and 45, there's a 15 degree difference. From 45 to 60, there's another 15 degree difference. And then from 60 to 90, that's another 30 degree difference. So right there, that does make up the 90 degrees. Those same increments take place as you go around the full circle. All right, now when it comes to radians, this can be a little bit trickier for people, but there is a pattern also. I'm going to see if I can do my entire page width here. I'm going to quite do this. I'm just going to rewrite these here. Remember that in a circle, 360 degrees is equivalent to 2 pi radians. 180 degrees is equivalent to pi radians. And then when we started talking about radians, we did talk about 90 degrees and how that's equivalent to pi over 2, and then 270 would be 3 pi over 2. Well, the rest of these radians then, what you're trying to do here is you want to think of it as it's splitting up this circle, okay? I'm going to start with the 30 degrees. And if you convert 30 degrees into radians, it will convert into pi over 6. And when I look at this here, if I take the top part of this circle and I take the 30-degree increments and break it up here, I have 6 equal sections here. Now, if from 0 to here, if that's 1 pi, think of it, that's 1 unit. So each of these is 1 part of that unit, and since there are a total of 6 of them, right here you are looking at the radian for 30 degrees to be pi over 6. It's 1/6 of 1 pi. If I take 2 of these, well, that would be 2/6. So 2 pi over 6, which is equivalent to pi over 3. If I went up here, that would be 3 pi over 6. Well, 3 over 6 is equivalent to 1/2. Next, I would go to 4 pi over 6, which that's equivalent to 2/3, so 2 pi over 3. Followed by here, a 5 pi over 6. And then I'd get to 6 pi over 6, and that is pi. Now, you could 100% go ahead and convert each of those degree measures, but also here, it's just really easy to come up with all those measurements. Then you can also do that for the bottom half of our unit circle here, and you just have to add on 1/6 and realize that you're making 2 pi radians in the end. So 6 pi over 6, the next one here would be 7 pi over 6. The next would be 8 pi over 6, and 8 pi over 6 would be the same thing as 4 pi over 3. Then it goes to 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which would be 5 pi over 3. Let's see, that was 10 pi, so then we go to 11, right? Yeah, 11 pi over 6. And then I would be going to 12 pi over 6, and 12 pi over 6 would end up giving us the 2 pi. And so here I've taken care of pretty much all of the radian measures with exception of I've got 4 left over. Now the last 4 that we're working with are working with the 45 degrees. And 45 degrees, when you think about 180 divided by 45 is 4. So we can split our top half of our circle here into equal fourths. So if I'm going to go 45 degrees, that is 1/4 of pi. If I go 2/4, well, 2 pi over 4 is equivalent to pi over 2. If I go to 3 pi over 4, and then I get to 4 pi over 4, which is 1. Take the bottom half of our circle and divide that into 4 equal sections. So now you got 4/4, which is pi. You got 5 pi over 4, 5/4. You got 6 pi over 4, which is equal to 3 pi over 2. And then you have 7 pi over 4, followed by 8 pi over 4, which would give us to 2 pi. So essentially, that is, and I guess I'm going to put it right here, that's where your unit circle comes from. And here's where I've got everything all listed for us. So now we're going to use this unit circle to evaluate different trig expressions, and using really the concepts of sine, cosine, and tangent. So a reminder to you that when we were on the unit circle and placing coordinates on the unit circle, that we found that the ratio of cosine was always your x coordinate divided by whatever the radius was. Same thing with y, or the sine of theta would be y over the radius, tangent would be y over x. Now, since we're on the unit circle, know that your radius now is now 1. This allows us to then transfer over to say that cosine of theta is equal to x. Sine of theta equals y. And so when we look at these coordinates that are provided for us, cosine of theta is always the first coordinate, and then the sine of theta is always the second. So when we think back to what we were doing when we started talking about sine, cosine, and tangent, and I take a look at 30 degrees. When I take the cosine of 30 degrees, so I'm going to rewrite this here. This is 1/2. This is the square root of 3 over 2. This is 1. When I take the cosine of 30 degrees, I'm taking the square root of 3 over 2 over 1. Notice that that is my x-coordinate. When I take the sine, I'm taking the opposite over the hypotenuse. I'm taking 1/2 over 1. Notice the 1/2 right there. And so this idea here that your coordinate is always cosine theta, sine theta. Think of it alphabetically as well. C comes before S. Now tangent is kind of its own special part here. Tangent, always think about the slope when it comes to your tangent, because it's telling you what your change in y over your change in x is, how steep that line is going to be. So now what we're going to do is we're going to use our unit circle to help us evaluate. So you're not going to use your graphing calculator, because that's not going to give you exact answers, because a lot of the answers are going to have square roots in them, but some answers they would work for, okay? So let's say you wanted to take the sine of 60 degrees. First of all, you got to locate where 60 degrees is. So here's 60 degrees, here's my coordinate. So when I'm looking at the sine of 60 degrees, I want to look at the y coordinate. And so my answer here is the square root of 3 over 2. Once again, if I were to set up my right triangle right here, this is 1/2. Here's the square root of 3 over 2 for the height, and my hypotenuse is 1. And so sine of 60, opposite over hypotenuse, square root of 3 over 2 over 1, which simplifies to the square root of 3 over 2. All right, next I take a look at the cosine of 5 pi over 6. So I need to locate where 5 pi over 6 is, which puts us over here in quadrant 2. Taking the cosine of 5 pi over 6, which tells us that we want to take the x-coordinate. So it's going to be negative square roots of 3 over 2. Now, calculators real quick. Clear this part. Maybe it's my calculator. There we go. Alright, so the first one that we did is we did the sine of 60 degrees. So I just want to show you real quick. Taking the sine of 60 degrees. There we have it. Now, it's not telling me that that's the square root of 3 over 2. But if I wanted to check my answer, I see that those are identical to each other. Now the next one, you're taking the cosine of a radian. So if you were doing that, you'd want to change your mode. And we'd need to be in radian mode. And here we're taking the cosine and 5 pi over 6. So I would do 5 pi divided by 6. And then I get negative 0.866. So that's negative square roots of 3 over 2. And what's nice about this here is that your calculator knows that 5 pi over 6 is in that second quadrant, so it knows to make that x value there negative. Sine of 330 degrees. So we locate 330 degrees. Here it is. Sine means that you are working with the y coordinate, and so that answer would be negative 1/2. Okay, cosine of 11 pi over 6. So I locate where 11 pi over 6 is right here. Cosine, I'm going to look at the x value associated with that, and so that would be positive square root of 3 over 2. So that is how you evaluate using your unit circle and not a calculator to find the exact value. What about if you wanted to get into tangents? Okay, now you can't just look at the coordinate this time. Now you're going to have to do a little simplifying. Because remember, tangent is y over x. It's the slope of that line. So, tangent of 240 degrees. I locate 240 here. Tangent is y over x. So, negative square roots of 3 over 2 divided by a negative 1/2. Remember that when you divide fractions, you are actually multiplying by the reciprocal. The 2's are going to cancel out. Those negatives make it positive. And we get the square root of 3 for the tangent. And that would be its slope. Notice if I go from the origin to that point right there, that line is positive as far as the steepness is going in the direction. And so square root of 3 over 1. How about tangent of 3 pi over 2? So 3 pi over 2 puts me right here. Here's my coordinates. So I take the y value, which is negative 1, divide that by 0. And anything divided by 0 is undefined. You have a vertical line. Your rise is negative 1, but your change in x is 0. So you can't divide by 0. Therefore, it's an undefined slope. It's a vertical line. How about 11 pi over 6? So we take a look at 11 pi over 6 puts us here. Here's my coordinate. So I have to take negative 1/2. Divided by a positive square root of 3 over 2. So some of you are going to get really good at simplifying these in your heads and not having to write them out. I'm writing them out so that you can see where those values are coming from. 2's will cancel out. I get negative 1 over the square root of 3. Rationalize that denominator, and we get negative square root of 3 over 3 for our tangent. And how about lastly then the tangent of 135. So 135 puts me here. Taking my y, which is the square root of 2 over 2, divided by a negative square root of 2 over 2. Anything divided by itself is 1, so our tangent is negative 1. Now one thing that you will notice is you will start to notice that the tangents do repeat themselves. I will leave it up to you, if you'd like to go ahead and find some of these tangents and include them. What you might want to do, say for example here, like I could put negative 1, and I think like when I use this on tests, I usually put a box around it just so I know that that's the tangent. When I look at 240 degrees, which is down here, this was the square root of 3 for its tangent, because you're going to be having reference to these later on, and this will save you a little bit of time. 11 pi over 6, which is negative square roots of 3 over 3. And like down here, this is undefined. Okay, so you know that at 90 degrees, that's the other part of that vertical line. So your tangent here has to be undefined. Pi over 4, you're taking square root of 2 over 2 divided by positive square root of 2 over 2. That slope is positive 1. I'm just going to say, like here, 11 pi over 6, that's negative square roots of 3 over 3. Well, at pi over 6, it's going to be a positive square root of 3 over 3 for its slope, because this slope is just going the positive direction, this one's going in the negative direction. So I will leave that up to you if you want to kind of fill in your unit circle to get those values. The other thing that you just have to be aware of is that you might have some angles that are not necessarily on your unit circle, but that's just because you're making multiple rotations. So you remember we talked about coterminal angles. So 390 degrees, well that is more than 360, and we got to kind of just figure out how much more than that. So by taking 390 and subtracting 360, I'm left with 30 degrees. So that means that you're making one complete rotation and then going to 30 degrees. Because you're rotating around a circle, your value of sine is not going to change. You're still looking for that y value here. So the sine of 390 degrees is equivalent to the sine of 30 degrees. And so in this case here, we will get 1/2. 390 degrees, your calculator is going to know that you're going into that first quadrant. So the sine of 390, I think, is what we said. Is that no 390? Yes. One second here. All right, now I was wondering why I was getting that answer there, but now I know why, because I am in radian mode, and I would need to be in degree mode if I'm going to check this, so sorry about that. So what do we do? Sine of 390. So notice it's giving me 1/2. Same thing I get when I take the sine of 30 degrees, okay? So you're just making an additional rotation with that. Degrees are always a lot easier than radians, it seems to be like for people. So with radians, I just suggest that people kind of think about counting it out. Cosine of 11 pi over 4. First of all, 11 over 4 is more than 2, and that's 2 pi radians is one rotation. So sometimes what I tell people to do is think about one rotation here is 2 pi. Well, in fourths, that would be 8 fourths. So then go to 9 fourths, 10 fourths, and then we make it over here to 11 fourths. So cosine of 11 pi over 4 is equivalent to taking the cosine of 3 pi over 4. And cosine in this situation, we'd be looking at that x value of negative square root of 2 over 2. What happens if you have a negative radian, or for that matter, a negative degree? You have to go in the opposite rotation. So negative 7 pi over 6. Now positive 7 pi over 6 would put me right here at 210 degrees. But I have to go in the opposite direction. So when I look at this here, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. Right here, this is going negative 7 pi over 6. So the tangent of negative 7 pi over 6 is equivalent to the tangent of 5 pi over 6. And eventually we talk about some properties that go along with these. And then tangent in this case here, we would be taking our 1/2, divide that by the negative square roots of 3 over 2, and we would get a negative square root of 3 over 3 for our tangent here. Alright, so I am going to leave it here. Now you should be able to answer the back side of homework number 6, working with your unit circle.